Hey everyone, here's a quick video on solving factorable quadratics, our day 2. So for the warm-up, it says algebraically determine the roots of the quadratic given the equation x minus 6 multiplied by x plus 8 equals 0. Now the first thing that you want to make sure is that the quadratic is set equal to 0, which it is, and factored, and it looks like it's already in factored form. So from here, all we have to do is tee it off and set each factor equal to 0. Now when I solve the equation on the left-hand side, one of my answers is x equals 6. And then on the other side, when I subtract the 8 over, we get x equals negative 8. Now if I were to look at that graph, it would cross the x-axis at x equals 6 and when x equals negative 8. Now the other day we looked at setting it equal to 0, factoring the one side, and setting both factors equal to 0. Now in this first section, we're going to look at it how we could do it without factoring. Now when I look at this equation, 2x squared equals 72, I'll notice that I only have one term right here, this 2x squared with the x. So I don't actually have to factor this one. I could start off by dividing by 2. And then I'll have x squared equals 36. And then from here, both sides are perfect squares, so I could take the square root, and I'll get x equals plus or minus 6. Now, usually you're used to only seeing the positive root, but technically when I take the square root of 36, I could have a positive 6 because 6 times 6 is 36, or I could have a negative 6 because negative 6 times negative 6 is 36. All right, now let's look at the second side. What is the solution set of the equation? 3x squared equals 48. On the left-hand side, you'll notice there's a term with an x squared. On the right-hand side, or on either side, there's not another term with an x. So from here, I could go about dividing by 3, divided by 3, and then I have x squared equals 16. Now from here, they're both perfect squares. To get rid of the exponent of 2, I'll take the square root, and x is equal to plus or minus 4. I'm just going to skip this one right here because it's very similar to the one that we did right above in that box. So if I look at the bottom one, it says solve 6x squared minus 42 equals 0 for the exact values. Now the exact values means you're not going to round, and you're going to probably have a final answer underneath the square root symbol. So from here, I'm going to solve it with factoring and then without factoring. So the first way, if I choose to factor it, I have it set equal to 0, which is good. Now I'm checking for a GCF. 6 goes into 6 and 42, so I'm going to pull out the GCF of 6. I have x squared minus 7 equals 0. And then I'm going to set each factor equal to 0. Here, 6 can't equal 0, so that's not good. Then here I'm going to add the 7 over. I have x squared equals 7, take the square root, and x is equal to plus or minus radical 7. So my final answer is plus or minus rad 7. Now I could do that without factoring, and I'll just kind of do it over here. I have 6x squared minus 42 equals 0. Again, I see that I have only one term with an x squared or an x in it, so I'm going to solve it like a normal equation. I'm going to add the 42 over. I have 6x squared equals 42. Then divide by 6, and then I have x squared equals 7. Then from here, take the square root of both sides, and I get x equals plus or minus radical 7. All right, now in this next section is kind of more similar to what we did on the first day. Most of these can be done with factoring. So when I look at this over here, I'm going to take the x and distribute out x squared minus 3x equals 10. But I need to make sure that it's set equal to 0 before factoring, because when you're solving for the root 0's x-intercepts, that's always when your y value is equal to 0. So I have x squared minus 3x minus 10 equals 0. Once it's in standard form, I'm going to check to see if it's 1 a.m. GCF or dots. This one is a 1 a.m. problem. So when I factor it, I need two numbers that multiply to negative 10, but also add up to negative 3. So I have x minus 5 and x plus 2. Once I factored, I'm going to tee it off and set each factor equal to 0 and solve those resulting equations. So here, when I add the 5 over, I get x equals 5. When I subtract the 2 over, I get x equals negative 2. Now, similar to this one on the left, it would be the same one on the right. You distribute that x out to the x and the negative 2, bring the 3 over. I'm going to skip that one. Now, when I look at this one right here, I have it set equal to 0. So that's the key part that I see is 0 here. So I don't have to double distribute this side. This side is already factored. So I'm going to tee it off and set each factor equal to 0. So from here, when I subtract the 8 over, I get x equals negative 8. On this side, when I add the 5 over, I get x equals 5. Now the one next to it is kind of different. Now I have x plus 4 to the second power equals 9. So I could rewrite this as x plus 4 multiplied by x plus 4 equals 9. I can double distribute and get x squared plus 4x plus 16 equals 9, and then combine like terms to get x squared plus 8x plus 16 equals 9, then subtract the 9 over, and then use 1 a.m. Or you can notice that this side, when I take the square root, will be a perfect square with the x plus 4 left over to get rid of the exponent of 2. And when I look at this, when I look at this 9, it is a perfect square. So instead of double distributing, from the beginning, I could start off by taking the square root of both sides. Now on the left-hand side, I'll be left with x plus 4 equals, and the square root of 9 is plus or minus 3. I need to do that plus or minus in front of the 3 because I could have two possible solutions. Now from here, to get rid of this plus 4, I'm going to subtract 4 to the other side. And now I have my x values can be negative 4 plus or minus radical 3. Now, negative 4 plus 3 is negative 1. And then I could have negative 4 minus 3, which is negative 7. Okay, so for the bottom left one, I'll see that there's a proportion. And every time I see a proportion, I should be thinking to cross multiply. So I'm going to take the x and multiply it by the x minus 1 and set that equal to 6 multiplied by 2, which is 12. Now from here, when I distribute out, I get x squared minus x equals 12. And I need to make sure that my quadratic is in standard form and also set equal to 0. So I'm going to subtract that 12 over and get x squared minus x minus 12 equals 0. From here, I'll see that I have a trinomial, the leading coefficient of 1, so I could use 1 a.m. I'm looking for two numbers that multiply to negative 12, but also add up to negative 1. So I have x minus 4 and x plus 3 equals 0 in factored form. And then from here, I'm going to tee it off and set each factor equal to 0. So I have x minus 4 equals 0 and x plus 3 equals 0. From here, add the 4 over. I have x equals 4, and then minus 3, x equals negative 3. And lastly, I have this one right here, negative 3x to the third power plus 42x squared minus 120x. For here, you'll notice that my degree of the polynomial is a 3, making this no longer a quadratic, but a cubic. Now, in order to factor cubics, you're going to have to pull out a GCF to force it to become a quadratic so that it could apply either 1 a.m., GCF, or dots to it. But from here, I also see that my leading coefficient is a negative. Now when I see that it's a negative, I need to pull out a negative GCF in order to make that x squared become a positive, or that x to the third to become a positive x squared. Okay, so I'm going to pull out a GCF of negative 3x. When I pull out a negative 3x, I'll have a resulting x squared minus 14x, and then negative 3x goes into negative 120, positive 40 times. And now from here, I'm going to look at the x squared minus 14x plus 40 and say to myself, I have a leading coefficient of positive 1. So I'm looking for two numbers that add to negative 14, but also multiply to 40. So when I think of those two numbers, I'm thinking negative 10 and a negative 4. So I'm going to bring down my GCF. I'm going to factor that trinomial as x minus 10, x minus 4. And then from here, instead of just teeing it off, I call it 3 it off because I'm going to set each of those three factors equal to 0 and then solve. So when I divide out by negative 3, I get x equals 0 as one root. When I add the 10 over, I get x equals 10. And then when I add the 4 over, I get x equals 4. So my answers are 0, 10, and 4. And just for this last one, since I have room, you'll also possibly see it written in your curly brackets, just saying that your solution set include the numbers 0, 4, and 10. So now, if you could, go back and try anything else that is blank. Thank you.